this formula. For that, gamma of minus 1 by 2, this will become minus of, because of minus 3 by 2 plus 1 is minus of, divided by minus 3 by 2. Next, reciprocal of this is minus 2 by 3. Again, use this formula, gamma of minus 5 by minus of plus 1 divided by n. Use this formula again. In place of n, take minus 1 by 2. So you will get gamma of half divided by minus 1 by 2. Gamma of half is 3 by 2. That's why we are doing this. We should reduce to gamma of half. Therefore, take this formula, reduce to gamma of half. Gamma of half is 1 by root pi. So this will be again reciprocal. Minus 1 by 2 reciprocal is minus 2 by 3 into minus 2 by 1. That will be 4 by 3 gamma of pi. Next, for this we have one more formula. Gamma of n plus of equal to, this is the formula, gamma of n plus of equal to 1 into 3 into 5 odd numbers divided by 2 power n divided by gamma root pi. This is 2 power n. So 7 by 2 you can write that as 3 plus half. Here n is 3. So here in place of n substitute 3. So what happens? 1, 3. If I substitute here 3, 2 into 3, 6. 6 minus 1, 5. 5 will be last number divided by 2 power 3 root pi. So this will be 15 by 8 root pi. Okay. So for this is the answer, 4 by 3 root pi. And for gamma of 7 by 2, this is the answer. Substitute back, you will get the answer. Okay, understood? Any doubt in that? Understood, right? Next, we'll go to properties of Laplace transforms. If L of f of t equal to f bar of s, then Laplace transform of e power at f of t equal to f bar of s minus a. What I am telling here is, in this property, what they are telling is, if you have Laplace transform, that is, if it is denoted by L of f of t is also nothing but f bar of s. If it is multiplied with exponential, if that function is multiplied with exponential, then replace s in place of s, write s minus a. That is the property. Laplace transform of f of t is equal to f bar of s. If e power at is multiplied, then substitute s by s minus a. See, once again somebody has problem. I will check what is that. Wait. So proof is not there. Just properties you need to remember. L of f of t equal to f bar of s, then L of e power at f of t is equal to f bar of s minus a. Wait, I will check whether proof is there on syllabus. Proof is not there. Just will remember the properties. That is one property. Then, so how that comes, let me explain. There should not be any confusion. L of f of t equal to, this is the basic definition of Laplace transform. L of f of t equal to 0 to infinity e power minus st f of t dt. That is also denoted by f bar of s. Let this be 1. Then e power at f of t we need. For that, what you have to do, in place of f of t, in place of this f of t, take e power at f of t. In place of f of t, take e power at f of t. So in place of this, in place of f of t, e power at f of t will be substituted. Correct? Now multiply this. Bases are same. Bases are same means this powers will be added. E power minus st, then at will be added, f of t as it is. Then take minus outside. If you take minus outside, s minus a will be left. See here, if you have here s means here f bar of s, here s minus a means here s minus a. That's all. If you have minus a, then s plus a. Next property, if L of f of t equal to f bar of s, then Laplace transform of t power n f of t equal to minus 1 power n d power n, that is not dn, d power n, d power n ds power n f bar of s, where n is a positive integer. Again, proof of this. So when I use this property, I will tell how this we will use. When we use in problems, I will tell how to use this. If I tell also, you will forget. That's why. Now, f bar of s is nothing but this. F bar of s is 0 to infinity e power minus st f of t dt. Differentiate with respect to s on both sides. D by ds of f bar of s. D by ds, if it goes inside, then ordinary differential will changes to partial. That will become dou by dou s. Then this will be the partial derivative of e power minus st is e power minus st into minus t. Correct? F of t. After that, multiply minus on both sides. This will be minus 1 e power, sorry, d by ds of f bar of s 0 to infinity e power minus st t f of t. This is nothing but in place of f of t, what you have? T f of t, t f of t you have. Therefore, L of f of t. This is verified for n equal to 1. So this is proved using mathematical induction. You know mathematical induction, how it will work. What are these three steps? We need to prove for n equal to 1. Then take it is true for n equal to n equal to k. First step is prove it is true for n equal to 1. After that, we have to prove it is also true for n equal to k. We will take it is true for n equal to k, then we will prove it is also true for n equal to k plus 1. That are these three steps. First one is n equal to 1, then it is true for n equal to k, then if it is true for n equal to k, it will also be true for n equal to k plus 1. Like that we need to prove. It is true for n equal to 1. Next we will assume that it is true for n equal to k minus 1 power k d power k ds power k f bar of s equal to L of t power n f of t. Now to prove this, minus 1 power k d power k ds power k, this Laplace transform definition L of f of t is 0 to infinity e power minus st f of t. F of t means t power k f of t dt. Differentiate again with respect to s. Why? Because we need to prove it is also true for n equal to k plus 1 minus 1 power k. So again differentiation means this will become k power 1, k plus 1, this is k plus 1. If you take this inside, is partial, ordinary will changes to partial dou by dou s. Now this will be dou by dou s means only this I have to differentiate. So derivative of this is e power minus st into minus t power k f of t, multiply minus on both sides. So already minus 1 power k is there. This will become k plus 1. So this will three terms as it is. Next here minus will become plus. Take this t inside. This will become t plus 1. Okay. So you got the here t power k plus 1 f of t. So this is definition of L of t power k plus 1 f of t. It is true for n equal to k plus 1 also. Therefore, by the method of the principle of mathematical induction, the result is true for all positive values of n. Okay, that is second property. This property is called as the derivative of transform property. Ooh, this is not visible properly. Okay, this is not scanned properly. If L of f of t equal to f bar of s, then L of f of t by t, this is t, is equal to s to infinity f bar of s ds. Okay, this is the third property. This is L of f of t equal to f bar of s, then L of f of t by t is equal to s to infinity f bar of s ds. First take f bar of s. F bar of s is 0 to infinity e power minus st f of t dt. Now take limits integration from s to infinity. So s to infinity again 0 to infinity as it is, this whole term as it is ds. On changing the order of integration, value will won't change. Okay, so change the order, this first, this next, e power minus st f of t dt ds dt. Now if you integrate this with respect to s, then e power minus st by minus t. If you substitute upper limit, that will be 0. Lower limit, e power s minus st by minus t only. Now if you multiply this minus with this, that will be plus. So e power minus st by t, take that 1 by t along with f of t. So f of t by t, this is nothing but L of f of t by t. Okay. this is, I think, this property, this one, L of 0 to t f of t dt. It is not there in the syllabus. I will check once again tomorrow in blow of syllabus. Then if it is there, then I will do. I think it is not there. Okay, these three properties are important. What are the three properties? This first one is this one, L of e power at f of t equal to f bar of s minus a. This is first one. Then this is second one. This property is also important. You will get problems on this. We'll do problems. Find the Laplace transform of the following functions. First one, e power minus 2t 2 cos phi t minus sin phi t. So first thing is, take this one which is not which is doesn't have e power at. Take that as f of t. Take this as f of t, 2 cos phi t minus sin phi t as f of t. First find Laplace transform of this. Laplace transform of this is 2 Laplace transform of cos phi t minus Laplace transform of sin phi t. Okay, in all the problems, if you have e power at, then take Laplace transform of the functions which doesn't have multiplied with e power at. Take that as f of t. Find Laplace transform for that. Okay, so Laplace transform of cos phi t, this is the formula. Cos at is s by s square plus a square. Then Laplace transform of sin at is a by s square plus a square. Substitute a value is 5 here, s by s square plus 5 square. Then again a value is 5 only, 5 by s square plus a square. So if you write this, denominator same, if you take the LCM, square plus 25 will be LCM, so 2s minus 5. Now for this, after finding out Laplace transform of this, just replace s by s minus a. Replace s by s minus a. Already here minus is there. By using this property, Laplace transform of e power at f of t is f bar of s minus a. In place of a, what you have? Minus 2 you have. So here if you write minus 2, s of s minus of minus 2, that is s plus 2. So this will give 2s minus 5, s square plus 25. How you got? By this. Replace s by s minus a. S minus a is nothing but s minus of minus 2, that is s plus 2. Wherever s is there, you need to write s plus 2. Okay, 2 into s plus 2 minus 5 divided by s plus 2 whole square plus 25. So solve this. 2s plus 2, 2 into 2, 4 minus 5 divided by a plus b whole square. A plus b whole square is a square plus 2ab plus b square plus 25 as it is. This is the answer. Before going to next problem, see once again, if you have any doubts in this, ask. No doubts. Understood? Understood or not listening? Only two, three responses I am getting. Okay, if you have doubts, you can just message me. I will go to next problem. Next problem. 1 plus, this is only right. Yes, 1 plus 3t e power 2t whole square. First thing is whole square is there. You need to expand using a plus b whole square formula. What is a plus b whole square formula? A square plus 2ab plus b square. Or a square plus b square plus 2ab. Both you can use. So a square, that is 1 square. Then 2ab, 2 1 to 6 t or 10 plus b square. B square is this whole square. This is whole square of this is 9 t square e power 2t. That e t. Next, Laplace transform of 1. Take Laplace transform to each term. Laplace transform of 1, Laplace transform of this, Laplace transform of this. So Laplace transform as it is in this, take out 6 outside, then Laplace transform of e. Then here take 9 outside, of e power 40 into t. After this, first find out Laplace transform of t. After that, substitute by s minus a. S a is s minus 2. Understood? Why? Because of first property. What first property? If exponential is multiplied, then find out Laplace transform of the function. Replace s by s. This property. So find Laplace transform of this. Substitute s by s minus a. So you will get Laplace transform of Laplace transform of should be replaced by s minus 4. What is Laplace transform of t? T power 1. T power 1 by 1 factor. Actually, my internet is very slow here. So please try to understand, or else if you have doubts, I will repeat that tomorrow. As we have holiday to college, we don't have fast internet. That's why please bear with this. I will take up to 10:30, and after that I will take attendance. That's all, because I don't have fast internet. So Laplace transform of Laplace transform of t is s by s of t is t power 1 is n factorial divided by s power n plus 1. Okay. Again, Laplace transform of t power 2 is 2 factorial divided by s power 2 plus 1. So, Laplace transform of 1 is 1 by s. Laplace transform of t is 1 by s square, but s should be replaced by s minus 2. And here Laplace transform of t square is 2 by s cube, but s should be replaced by s minus 4. Okay. So this is 1 by s. This is 6 by s minus 2 whole square plus 9 into 2 into s 2 divided by s minus 4 whole cube. Okay. This is second problem. Next, third one, cos hyperbolic t sine cube 2t. Cos hyperbolic 2t means, first thing what we have to do, we have to write cos hyperbolic t as e power, wait, this is different problem. This problem, change this problem. This is not cos h t sine cube 2t. This is sine hyperbolic ht sine at. Okay, I have written wrong. Third problem is sine h at sine at. Okay, change that. Got. You need to change this cos hyperbolic t sine cube 2t. We'll do that in fourth problem. This one, third problem is sine hyperbolic at sine at. Remember this. In notes also, you need to change. So, which I sent, you need to change to sine hyperbolic t sine at. First thing is, what we need to do, we need to change sine hyperbolic at to exponential. How to change? E power at minus e power minus at divided by 2. Next, multiply this e power at sin at, then this one minus e power minus at sin at. 1 by 2 outside. First, we need to find Laplace transform of this. Laplace transform of sin at, s should be replaced by s minus a. S should be replaced by s minus a. Why? Because it is multiplied with a, multiplied with e power at. Therefore, s should be replaced by s minus a. Here also, Laplace transform of sin at, s should be replaced by s minus a is nothing but s plus a. So, what is Laplace transform of sin at? A by s square plus a square. So, replace here s by s, sorry, a by s square plus a square, but here s should be replaced by s minus a. So, what happens if you replace s by s minus a? Here a by s minus a whole square plus a square, and here a by s plus a whole square a square. Okay, here I have written. Next, expand this. S minus a whole square is s square plus a square minus 2as, because A minus B whole square formula. Wait, screen sharing has stopped. Due to network issue, screen sharing has ended. Please wait. Sorry, here the network problem is there. That's why I can't able to share the screen. Wait, I will join again. Now you are seeing and listening, right? Okay. Now Laplace transform of sin 80 is a by s minus a whole square plus a square minus a by s plus a whole square plus a square. Next, s minus a whole square formula is a square minus b square whole b by a minus b whole square formula. Apply that. Again a plus b whole square formula. Apply that. Then this a square is 2a square. Here a square is 2a square. So take the LCM 1 into all these things. Here a into all these things. If you take the LCM, a square will get cancelled. 2a square will get cancelled. Then 4as will remain. Okay. So you can write this as a minus b, a plus b. Okay, a minus b, a plus b is a square minus b square. Okay, like that we are writing. This whole, which I marked, this is treated as a, this is b. a minus b, a plus b. Don't get confused with squares. This whole thing is regarded as a, this whole thing is regarded as b, then this is regarded as a, and this is regarded as b. So a minus b into a plus b. A minus b into a plus b is a square minus b square. So if you apply that formula, this will be a square plus 2a square whole square minus 4a square square. So Laplace transform of sin hyperbolic at sin at is 2a square sb divided by a square plus 4a power 4. Now we'll come to cos hyperbolic t sin cube 2t. You're hearing voice clearly, right? Okay. Cos hyperbolic t sin cube 2t. First thing is, write this cos hyperbolic t as exponential. Then it will reduce us to first property like a power. So how we did in this previous problem, this problem sin hyperbolic at sin at. For this one we reduce to exponential. Then we calculated what is Laplace transform of this. Similarly, for this will reduce to exponential. We need to first find Laplace transform of this. So Laplace transform of this, how to find out? First use that formula sin cube at, sin cube x formula. You have to use sin cube x formula. Sin cube x formula is 1 by 4 3 sin x minus sin 3x. 1 by 4 3 sin x minus sin 3x. This formula you have to use. So if you use that formula for this, 1 by 4 3 sin 2t minus 6 sin 6t. So what happens? This will be Laplace transform sin cube 2t will be 1 by 4 outside, 3 outside here, sin 2t minus Laplace transform of sin 6t. For this, use that formula. Sin 2t will be, what is Laplace transform of sin at? A by a square plus a square. So this will be 2 by a square plus 2 square. Again, Laplace transform of this will be 6 by a square plus 6 square. Okay. So what happens? 3 into 2, 6 by a square plus 4 minus 6 into a square plus 36. Take the LCM. LCM is nothing but 6 into all this thing minus 6 into all this thing. So this will be cancelled out. 6x square minus 6x square. So 6 into 36 is 216 minus 6 into 4 is 24. So 192 by this. This is answer for Laplace transform of sin cube 2t, not for complete one. Now what we have to do? Write this cos hyperbolic t as e power t plus e power minus t divided by 2. Write this cos hyperbolic t as e power t plus e power minus t divided by 2. Then this will be as it is. Now multiply this sin cube 2t to each term, to e power t into sin cube 2t plus e power minus t into sin cube 2t, 1 by 2 outside. Then Laplace transform of this will be, since exponential is there, Laplace transform of this will replace s by s minus 1. Laplace transform of this sin cube 2t replace s by s minus 1. Again, for this Laplace transform of this replace s by s plus 1. So already we calculated Laplace transform of sin cube 2t. Here we calculated Laplace transform of sin cube 2t. So Laplace transform of sin cube 2t, write that answer. Wherever s is there, write s minus 1 here. Wherever s is there, write s plus 1 in this. Okay, this is Laplace transform of sin cube 2t. So here write s minus 1 for first term. For this, write s plus 1 is in first term, s minus 1. In second term, write s plus 1. Okay, this is the answer. Understood? Any doubt in this exponential? Then I will go to next problem. T cos 80. T cos 80. This is second property for problem. Using second property, we need to solve this. So what is second property is telling here, t power n f of t is equal to minus 1 power n d power n ds power n Laplace transform of t power n f of t is minus 1 power n d power n ds power n, then f bar of s. Okay, I have not written that formula. So what is the formula? Laplace transform of, is it possible to write? Laplace transform of t f of t equal to t f of t equal to minus 1 power minus 1 power n minus 1 power n d power n divided by, sorry, it became 6, d power n divided by ds power n into f bar. I can't write. Oh, is it possible? I will try. 6 dash f bar of s. That is f bar of s. I can't write f bar. So this is the formula, d power n ds power n f bar of s. Okay, use that formula. This is t power n actually, not tf of 10. T power n. T power n f of t equal to minus 1 power n d power n divided by ds power n f bar of s. I can't write f bar here, so again I lost connection. I will just take attendance. I'll continue from there in next class. You're hearing right? So answer your attendance. Yes and one. Asta.
Present, sir.
Okay, Asta present. Uh, Next, Abdullah. Yes and two.
Present, sir. Present, sir.
Okay. Three,
Present, sir.
four,
Present, sir.
four, Abhishek.
Present, sir.
Abhishek absent.
Present, sir. 4.
Five. Abhishek.
Sir, 5 present.
Varnathal. Okay. He came later. Just message.
Sir, USN 5 present.
7.
Sir, 6 present.
Yes, yes. 6. 6 present. 7.
Present, sir. 7 present, sir.
Aditya Agarwal.
Yes,
8.
sir.
8 present, sir.
8 present. 9.
9 present, sir.
Okay. 10.
10 present, sir.
11.
11 present, sir.
11 present. 12.
12 present, sir.
12 present. 13. 13 Amog. Mega present. 13 present. 13. 13 present. Okay, 13 present. Amoga Bharadwaj. Just message in chat box. 14 present. Next 15. 15 present. 16. 16 present. 17. 17 present. 18. 18. Ankit Singh. Yes. 19. 19 present. 20. 20 present. 21 Apurva present. 22. Wait. 24, 26, 27, 27, Shreyas, 27, 28, 29, 30, 31, 32, 33, 33, Chirag, 34, 34 present, 35, 35 present, 36, 36 present, 37, 37 present, 38, Deepa, Deepa present,